The cosmos hides secrets that defy our very understanding of reality. Out in the silent dark, astronomers have found objects so strange they seem to break the laws of physics. We're about to journey through 25 of the most bizarre discoveries ever made beyond our world. You will encounter stars that flicker like signals from another intelligence and interstellar visitors that arrived from the void. By the end, you will see the universe as a place of endless mystery and wonder. What awaits us is a rogue black hole tearing through space, and a signal so powerful it was never heard again. What do you believe is waiting for us in the great unknown? A single burst of radio energy, so powerful and so specific, it was circled on a printout with the word, "Wow." In the summer of 1977, the Big Ear radio telescope in Ohio was quietly listening to the cosmos when it recorded something extraordinary. For 72 seconds, a signal flooded its receiver. It was a narrow-band radio wave, the kind theorized to be a potential signature of artificial technology, and it was 30 times stronger than the background noise of space. It appeared to originate from a region in the constellation Sagittarius, a point in the sky devoid of any known stars or planets at the time. The astronomer who discovered the data, Jerry Amon, was so stunned he famously scribbled "Wow" in red pen on the computer printout, giving the signal its legendary name. The very nature of the signal is what makes it so compelling. It was not a repeating pattern or a random burst of static. It was a clean, focused whistle that rose and fell in intensity exactly as you would expect from a source passing through the telescope's fixed field of view. It was a perfect candidate for a deliberate transmission, yet, despite decades of searching, that perfect signal was never heard again. The silence that followed has been louder than the signal itself. Was it a one-time glitch, a passing natural event we simply do not understand? Some have proposed it was a signal from a passing comet, though that theory has been largely debunked. Others suggest it was a reflection of a human-made satellite off a piece of space debris. But the most haunting possibility remains that for just 72 seconds, we accidentally overheard a message, a cosmic hello that came and went before we could even begin to reply. The wow signal endures not as an answer, but as a permanent question mark etched into our history, a ghost in the machine of the universe that continues to whisper, "What if?" While the wow signal remains a ghost in the void, another mystery hangs in the sky, one of breathtaking geometry. Orbiting the sun is a planet displaying a shape that should not exist on such a scale. At Saturn's North Pole, a perfect hexagon of clouds, wider than two Earths combined, spins in a perpetual and impossible dance. This is not an artist's rendering or a trick of the light. It is a real, persistent structure, a six-sided jet stream that has baffled astronomers since its discovery. The Cassini spacecraft, during its long mission, returned images of this phenomenon that were so clear and so stunning they seemed to defy logic. How could a perfect geometric shape, one you might draw with a ruler, form naturally in the turbulent atmosphere of a gas giant? The answer lies in the strange physics of fluids in motion. Scientists believe the hexagon is a massive, stable atmospheric wave, a kind of standing wave frozen in place by the planet's rapid rotation. You can see a smaller version of this principle by stirring a cup of tea. As you stir, tiny vortices and patterns can form in the liquid. Now, imagine that on a planetary scale, with the deep, churning atmosphere of Saturn acting as the fluid and the planet's spin providing the stir. The precise conditions have somehow locked this wave into a six-sided pattern, with each side being a jet stream wind racing along at over 300 miles per hour. What continues to mystify researchers is not just its formation, but its incredible endurance. This hexagon has been observed for decades, maintaining its sharp, precise structure through Saturn's long seasons, a stable monument in a storm. It is a natural wonder that looks utterly artificial, a cosmic signature that reminds us the universe holds patterns and orders we are only beginning to comprehend. Yet even Saturn's geometric perfection is a predictable wonder, unlike the star that behaves as if it is broken. Far away in the constellation Cygnus lies a sun named Tabby's star, officially known as KIC 8462852. To astronomers, it is the most mysterious star in the entire galaxy. Its story begins with data from the Kepler Space Telescope, an observatory designed to find planets by watching for the tiny, periodic dimming that occurs when one passes in front of its star. Most stars show these predictable, gentle dips, but Tabby's star did not play by the rules. Its light would plummet erratically, not by a mere fraction of a percent, but by staggering amounts up to 22%. That is an immense drop, far too large to be caused by any ordinary planet. It was as if something colossal and utterly bizarre was passing in front of it, blocking its light in a chaotic, unpredictable dance. The hunt for an explanation began, and the theories were as wild as the data. Some scientists proposed a colossal swarm of comets, thousands of them, breaking up and casting vast shadows. Others wondered if it was a cloud of interstellar debris, the aftermath of a planetary collision. But the most captivating and mind-bending idea was that of an alien megastructure. Imagine a civilization so advanced it builds a vast network of solar collectors around its star, a partial Dyson sphere, to harness all of its energy. Such a structure would not be a solid shell, but a ragged swarm of orbiting panels, and that could perfectly explain the star's strange, irregular dimming patterns. For a time, this was a serious, if speculative, point of discussion. The allure of a potential sign of intelligence was undeniable, yet science demands answers, and further observation has slowly peeled back the layers of the mystery. Detailed analysis of the starlight revealed that the material blocking it behaves not like solid panels, but like fine dust. The dimming is more pronounced in some wavelengths of light than others, a telltale signature of tiny particles. The latest research strongly suggests a vast, uneven cloud of cosmic dust, perhaps from a devoured moon or a disrupted planet, is the most likely culprit. But the case is not fully closed. The origin of all that dust and the reason for its truly extreme behavior remains an active puzzle. Tabby's star stands as a monument to cosmic strangeness, a reminder that even when the most fantastic explanations fade, the universe still holds profound and natural mysteries waiting to be solved. So the hunt for a solid megastructure began to crumble under the weight of new evidence when powerful telescopes like Hubble and the Las Cumbres Observatory turned their gaze toward Tabby's star. They were looking for a specific clue in the starlight itself. By breaking that light into its constituent colors, a technique called spectroscopy, scientists could determine what kind of material was blocking the star. A solid, opaque object, like a planet or even an alien solar panel, would block all wavelengths of light equally, but that is not what they saw. Instead, the dimming was uneven. The starlight was being blocked more in some colors, particularly the blue and ultraviolet, than in others. This is the classic fingerprint of dust. Fine, microscopic particles smaller than a grain of sand scatter blue light more effectively, just like our own atmosphere makes the sky appear blue. This single observation shifted the entire mystery. It was not a solid, monolithic structure casting a shadow, but a vast, swirling cloud of incredibly fine dust. But where did all this dust come from, and why was there so much of it? The current leading theory is as catastrophic as it is fascinating. Astronomers now suspect a colossal disruption in the star's system. One compelling idea is that a giant exomoon was torn from its planet, perhaps by a gravitational slingshot, and was ripped apart by the star's immense gravity. This would have created a gigantic, expanding cloud of debris, a chaotic ring of pulverized rock and ice that now orbits the star in a lopsided, clumpy swarm. Another possibility is a giant impact, like the one that formed our own moon, but on a far more immense scale, vaporizing entire worlds into a shroud of fine particulate. As this cloud continues to drift and spread, its denser clumps pass in front of the star, causing those dramatic, irregular dips in brightness. The legacy of Tabby's star is not the discovery of aliens, but something almost as profound for science. It forced astronomers to develop new, more sophisticated tools to analyze starlight. It taught them to look beyond the simple, repeating dips of planets and to consider more exotic, chaotic possibilities hiding in the data. This one strange star revolutionized the search for cosmic anomalies, proving that the universe is not just a place of order, but also of beautiful, destructive chaos. The universe specializes in beautiful chaos, but it also sends us visitors from the void. In October 2017, astronomers spotted an object moving so fast it could not possibly be from our own solar system. It was the first confirmed interstellar traveler ever observed, and they named it Oumuamua, a Hawaiian word for scout or messenger from the distant past. It was a tiny, faint speck of light, but its trajectory was a revelation. It had come from the direction of the constellation Lyra, having journeyed for millions of years through the empty space between stars before slingshotting around our sun and hurtling back out toward the constellation Pegasus. The brief window to study it sent a shockwave through the astronomical community, for this scout was unlike anything we had ever seen. Its shape was the first great surprise. Based on how its brightness changed dramatically as it tumbled end over end, scientists deduced it was highly elongated, perhaps 10 times as long as it was wide. It resembled a cosmic cigar or a flattened pancake, a shape rarely seen in our own solar system and completely unnatural for any known asteroid or comet. Then came the second and greater mystery. As Oumuamua raced away from the sun, it did something inexplicable. It sped up. Any object propelled by gravity alone should slow down as it escapes the sun's pull, like a ball thrown upward on Earth. But Oumuamua was experiencing a non-gravitational acceleration, a gentle but persistent push that defied a simple explanation. The most common cause for such a push is a comet. When a comet's ices heat up near a star, they vaporize and jet out, acting like a tiny rocket engine. But Oumuamua showed no signs of this activity. It had no visible coma, the fuzzy envelope of gas and dust that always surrounds a comet's nucleus. It was dark, reddish, and utterly silent, offering no hint of the outgassing that should have been causing its acceleration. This silence sparked a fierce and fascinating scientific debate. What was pushing it? One theory proposed it was a hydrogen iceberg, a chunk of solid molecular hydrogen that would sublimate in the sun's warmth, producing an invisible jet that pushed the object without creating a dusty coma. Another, more exotic idea came from Harvard astronomer Avi Loeb, who suggested we could not rule out an artificial origin. Could it be a piece of alien technology, a discarded light sail from an advanced civilization, using the pressure of starlight itself for propulsion? The very properties that made it so strange, its unusual shape and its non-gravitational acceleration, were consistent with a thin, lightweight sail. While most scientists favor a natural explanation, the hydrogen iceberg theory has its own problems, as such a fragile object might not survive the long journey through interstellar space. Oumuamua is now far beyond the reach of our telescopes, a silent enigma receding into the darkness. Its brief visit left us with more questions than answers, a profound puzzle that forces us to reconsider what kinds of objects travel between the stars. Was it a strange new type of comet, a fragment of a shattered world, or something else entirely? We may never know for sure, but its legacy is undeniable. It was our first tangible touch from another solar system, a messenger that proved the galaxy is filled with wonders we have not even begun to imagine. The mystery of its acceleration demanded a natural culprit, and a new theory emerged from the cold. What if Oumuamua was not a rock or a hydrogen iceberg, but a cosmic snowball made of something far more familiar? Scientists proposed it was a chunk of solid nitrogen ice, a shard blasted off the surface of a distant, Pluto-like world in another star system. This idea elegantly solves two puzzles at once. As the nitrogen ice warmed in its close pass by our sun, it would have sublimated, turning directly from a solid into a gas. This process would have given Oumuamua its gentle, non-gravitational push, just like a comet's jet, but without producing the dusty grains that create a visible coma. The evaporating nitrogen gas would have been invisible to our telescopes, a stealthy engine perfectly explaining the acceleration. Furthermore, a slab of nitrogen ice would be highly reflective, which aligns with the object's unusual brightness. Its strange, flattened shape could also be explained by this origin story. Just as glaciers on Earth calve off large, flat icebergs, a planetary collision or a close gravitational encounter could have sheared off a large, flat piece of a nitrogen-rich crust, sending it on a million-year journey into the void. While the debate is not fully settled, the nitrogen iceberg hypothesis stands as one of the most compelling natural explanations for our first interstellar guest. Its legacy, however, stretches far beyond a single theory. Oumuamua was a wake-up call. It proved that interstellar objects are not just theoretical, but are passing through our cosmic neighborhood with some frequency. Its brief visit ignited a global effort to find the next one. New sky surveys, like the powerful Vera C. Rubin Observatory, are being fine-tuned to scan the heavens for these fast-moving visitors. They promise to catch the next one earlier, giving us more time to train every available telescope on it. The existence of Oumuamua and the newer interstellar comet Borisov that followed tells us something profound about the universe. The building blocks of planetary systems are not unique to our own sun. The same kinds of materials, the same ices and rocks that formed our outer planets and comets, are common throughout the galaxy. These travelers are more than just rocks. They are messengers carrying the chemical secrets of their birth, clues to the formation of worlds orbiting other stars. Oumuamua opened a new window into the cosmos, a window through which we now know we are not an isolated island, but part of a vast, interconnected archipelago of solar systems, all trading material across the light years. These interstellar travelers reveal a universe rich with exchange. But what if the greatest cosmic mystery is not what is out there, but what is not? In the seemingly uniform tapestry of the cosmos, there exists a hole. Not a small gap, but a staggering spherical emptiness so vast it challenges our understanding of the universe's structure. This is the Boötes Void, discovered in 1981, a region of space so profoundly empty it has earned the chilling nickname the Great Nothing. Imagine a sphere so wide it would take a beam of light 330 million years to cross from one side to the other. Now, picture that immense volume being almost completely devoid of galaxies. Where astronomers would expect to find thousands, perhaps even 10,000 galaxies, they have found only a few dozen. It is a cosmic desert on a scale that is difficult to even comprehend. Our own local group of galaxies, including the Milky Way and Andromeda, would be a tiny, insignificant speck if placed inside this void. The existence of such a place forces us to ask, how can something this empty even form? The leading theory points to the gravitational tug-of-war that has shaped the universe over billions of years. The cosmos is not a smooth soup of matter, but a web, a vast structure of dense filaments and clusters where galaxies gather, separated by enormous bubble-like voids. Scientists believe the Boötes void may be the result of smaller voids merging together over eons, like soap bubbles combining to form one gigantic empty cavity. The gravitational pull of the surrounding dense regions would have slowly siphoned matter away from the center, leaving behind this incredible emptiness. But the sheer scale of the Boötes void pushes this idea to its limit. It is so large that some cosmologists wonder if it is a sign of something else entirely, a flaw in the fabric of the universe or an imprint from a time before the Big Bang. Could it be evidence of a cosmic structure so grand we lack the language to even describe it? Gazing into the great nothing is not just about counting missing galaxies. It is a profound reminder that the emptiness between the stars is not truly empty, but is itself a feature, a shape, a part of the universe's architecture. The void asks us a silent, haunting question. Is this immense nothingness a natural consequence of cosmic evolution, or is it a glimpse into a deeper, darker level of reality we have not yet begun to see? While voids show us the architecture of emptiness, some cosmic structures display a geometry of breathtaking precision. In the faint constellation of serpents, a perfect circle of starlight drifts through the dark. This is Hoag's object, a galaxy so strange and beautiful it seems more like a celestial dream than a real island of stars. Discovered in 1950 by astronomer Art Hoag, this ring galaxy presents a puzzle that has endured for decades. At its heart lies a dense, spherical core of old yellow stars. Surrounding it, at a vast distance, is a perfect, separate ring of young, brilliant blue stars, all set against the black velvet of space. The most striking feature is the gap between them, a dark, seemingly empty chasm that cleanly separates the core from the outer ring. It looks less like a naturally formed galaxy and more like a cosmic bullseye. The immediate question is, how could such a perfect structure come to be? In most spiral galaxies, like our own Milky Way, curved arms of stars are connected to the central bulge by a bar of stars and gas. But Hoag's object has no such bar, no visible bridge of matter linking its core to its ring. This pristine separation is the heart of the mystery. The most widely accepted theory is one of cosmic violence. Billions of years ago, a smaller galaxy may have plunged directly through the center of what was then a normal spiral galaxy. The gravitational shockwave from this collision would have sent waves of stars and gas rushing outward, much like a pebble dropped in a pond. As this expanding wave of material reached a certain distance, it compressed, triggering a frenzy of new star formation. This would have created the brilliant blue ring we see today, while the central core, largely undisturbed by the event, was left with its older, yellow stellar population. Another theory suggests a process of extreme resonance, where gravitational instabilities within the galaxy itself naturally organize the material into separate rings over eons, without any collision at all. Yet neither explanation is entirely perfect, and the quest to understand this celestial oddity continues. Hoag's object remains a singular vision, a rare and exquisite example of cosmic order born from either chaos or quiet evolution, a perfect circle of stars, forever questioning our ideas of how a galaxy can live and die. From the perfect geometry of a ring galaxy, we journey to a dying star's final, artistic masterpiece. In the constellation Monoceros, a celestial painter seems to have been at work, creating a structure of such precise beauty it was named the Red Rectangle Nebula. This is no hazy cloud of gas. Through the powerful lenses of the Hubble Space Telescope, it reveals itself as a series of concentric, rung-like rectangles, glowing with a deep, rich crimson light. At its very heart lies a pair of aging stars, locked in a tight gravitational dance. These binary stars are the architects of this stunning spectacle. As one of the stars nears the end of its life, it has begun to shed its outer layers into space. But this is not a messy, chaotic death. The gravitational pull of the two stars whipping around each other focuses this expelled material, funneling it into two opposing cones of dust and gas. From our vantage point here on Earth, we are looking directly at the base of these cones, seeing them edge on. This perspective is what transforms the twin cones into the illusion of a stacked series of red rectangles, a cosmic ladder reaching out into the void. The intense stellar winds from the hot, central star heat and illuminate this expelled material, making it glow, but the mystery deepens with the source of its remarkable color. The vibrant red hue is not just from glowing hydrogen gas, a common sight in nebulae. The red rectangle is shining with a specific type of red light emitted by complex organic molecules known as polycyclic aromatic hydrocarbons. These are large, carbon-based molecules, the same kind of compounds found in soot right here on Earth. This nebula is essentially a vast, interstellar chemical factory, forging the building blocks of more complex materials in the turbulent outflow from a dying star. It serves as a breathtaking laboratory, showing us how the raw ingredients for life itself can be created and scattered throughout the galaxy, seeded into the clouds that will one day form new stars and planets. The red rectangle is more than a pretty picture. It is a promise written in gas and dust, a hint that the universe is not only strange and beautiful, but also profoundly fertile. That same cosmic architecture might be hiding a current flowing through the entire observable universe, a strange and controversial motion detected in the faint afterglow of the Big Bang itself, hints that something immense is pulling at the very fabric of our reality. This is the mystery of the dark flow. The story begins with the Wilkinson Microwave Anisotropy Probe, a satellite designed to map the cosmic microwave background, the leftover heat from the universe's birth. This background is remarkably uniform, but scientists using its data noticed something peculiar when they studied huge clusters of galaxies. They found that these clusters, hundreds of millions of light years across, were not moving randomly. Instead, a vast number of them appeared to be streaming in a common direction at incredible speeds, over 2 million miles per hour. This was not the general expansion of the universe, but a coordinated drift, as if caught in a cosmic river. The sheer scale of this motion is what makes it so difficult to explain. The gravitational pull from all the visible matter we can map in the universe should not be strong enough to cause this. So what is pulling them? The most mind-bending possibility is that the dark flow is evidence of something beyond the horizon of our observable universe. We can only see so far because light has had only 13.8 billion years to travel to us, but the universe itself may be much, much larger than this observable bubble. The theory suggests that the gravitational tug of a massive, unseen structure, a concentration of matter so vast it lies outside our cosmic light cone, is exerting its influence on everything inside our visible realm. Imagine you are in a room with no windows, but you feel a constant, gentle breeze. You cannot see its source, but you know there must be a door or a window open somewhere beyond the walls. The dark flow could be that breeze, a whisper from a part of the cosmos we can never directly see. This concept, if proven, would be revolutionary. It would mean our entire universe, everything we can observe, is just one island in a far grander archipelago of realities, part of a potentially infinite multiverse. The scientific community remains deeply divided. Some argue it is a statistical fluke or an artifact of the measurement process. Yet, if the dark flow is real, it points to a cosmos of unimaginable scale, where the pull of other universes or other domains of our own might already be guiding the journey of the galaxies. This coordinated drift of galaxies points toward a specific and powerful source. Lying in the direction of the constellations, Centaurus and Hydra, is a gravitational enigma known as the Great Attractor. For decades, Astronomers have known our Milky Way is not drifting aimlessly through the cosmos. Along with our entire local group of galaxies and thousands of others, we are all being pulled in a specific direction at an astonishing speed of over 1 million miles per hour. The source of this immense pull is the Great Attractor, a focal point of gravity so powerful it dominates the motion of an entire sector of the universe. For a long time, its true nature was one of astronomy's most frustrating mysteries, hidden from our view by a cosmic curtain. This curtain is what scientists call the zone of avoidance. It is the thick plane of our own Milky Way galaxy, a dense band of gas, dust, and countless stars that blocks our optical view of what lies beyond. Trying to see the Great Attractor with a visible light telescope was like trying to see a distant mountain range through a dense, blinding fog. The very center of the mystery was located in the one part of the sky we could not easily see. The breakthrough came when we learned to look with new eyes. Modern astronomy, using X-ray and infrared telescopes, can peer through this obscuring veil. X-rays punch through the dust, while infrared light, which has longer wavelengths, is not scattered as easily. These new views revealed the secret. The Great Attractor is not a single, impossibly dense object, but a colossal concentration of mass, a massive supercluster of galaxies. This region, now known as the Norma Cluster, contains an immense gathering of galaxies and, more importantly, enormous amounts of dark matter, whose gravitational pull is the true engine of the attraction. Yet, even with this revelation, the puzzle is not completely solved. The sheer number of galaxies and the calculated mass of the dark matter in this supercluster are immense, but some scientists calculate that it may still not be enough to fully account for the observed velocity of our galactic motion. This suggests the Great Attractor itself might be just a waypoint, a local manifestation of an even larger and more distant gravitational source further down the cosmic river, pulling everything toward an unseen destiny. The Great Attractor reminds us that we are not just observers of the cosmos, but participants in a grand gravitational dance, moving toward a center we once could not see, guided by forces we are still striving to fully understand. That same gravitational dance hints at a hidden partner, a phantom galaxy we can feel but not see, while the Great Attractor pulls us from afar. A more local mystery tugs at the very edges of our own Milky Way. Astronomers call this hypothetical object Galaxy X, a massive, invisible entity thought to be orbiting our own, its presence betrayed only by the ghostly ripples it leaves behind. The evidence for this dark galaxy comes not from light, but from motion. Observations of the vast, sparse cloud of atomic hydrogen gas that surrounds our galactic disk revealed something strange. This outer disk is not smooth and placid. It is warped and rippled, like a pond disturbed by a stone thrown into its center, but there was no visible stone. The pattern of these perturbations, the specific way the gas was being stirred, strongly suggested the gravitational influence of a substantial, compact mass passing through it. The leading theory proposed that a dwarf galaxy, one containing very few stars but immense amounts of dark matter, had made a close pass by the Milky Way. This dark matter halo would exert a powerful gravitational pull, tugging on the hydrogen gas and creating those lasting ripples, all while remaining almost completely invisible to our telescopes. The search for Galaxy X became a hunt for a cosmic phantom. Astronomers scanned the proposed region of sky, looking for any faint, overlooked star clusters or streams of stars that might be the sole visible tracers of this massive dark object. Some researchers believed they found supporting evidence in the motion of certain globular clusters and distant stars, whose paths also seemed to be influenced by this unseen mass. Yet, the case for Galaxy X is far from closed. The primary challenge is its proposed darkness. A galaxy with so much mass should, according to our current understanding, have managed to form at least some stars. Finding absolutely nothing visible seems to push the limits of what is plausible. Furthermore, alternative explanations for the ripples in the hydrogen disk exist. Some scientists suggest they could be the lingering echoes of an ancient collision with a smaller, visible galaxy like the Sagittarius dwarf, whose remnants are still being absorbed by the Milky Way. The gravitational wake from such a past event could have set the gas oscillating for billions of years. The true power of the Galaxy X hypothesis is not whether it is ultimately proven true, but how it forces us to confront the limits of our vision. It represents a fundamental shift in how we map the cosmos, moving from a search for what shines to a search for what pulls. We are learning to see with the eyes of gravity, to sense the presence of hidden giants by the subtle wobbles they impose on the visible universe. This is the new frontier of astronomy, a hunt for the invisible architecture that holds our galaxy together. But the invisible giants of our cosmos are not always made of dark matter. Some are built of stars, yet are so faint they barely exist at all. Drifting in the Coma Cluster, a dense gathering of over 1,000 galaxies, is a phantom known as the Dragonfly Galaxy. In size, it is a titan, stretching across the heavens with a diameter comparable to our own Milky Way. But that is where the similarity ends. Where the Milky Way blazes with hundreds of billions of stars, the Dragonfly contains a mere 1% of that number. Its stars are scattered so thin that the galaxy is almost perfectly transparent, a wispy cloud of stellar light so diffuse it was only discovered in 2015, after specialized optics were built to filter out the distracting glare of other galaxies. This was not a matter of finding a needle in a haystack, but of seeing the haystack itself for the very first time. The existence of such an object in the Coma Cluster is a profound puzzle. Galaxy clusters are cosmic battlefields, places of intense gravitational turmoil. The space between galaxies is filled with a searing hot plasma, and galaxies themselves whip past each other at incredible speeds. In such a violent environment, conventional wisdom said a galaxy as flimsy as Dragonfly should have been torn apart eons ago. Its delicate structure should have been shredded by gravitational tides, or its sparse gas should have been ripped away by the pressure of the intergalactic wind. Yet there it is, a cosmic ghost that has somehow endured. How did it survive? Astronomers are investigating two compelling and equally fascinating theories. The first is that Dragonfly is a failed galaxy. Perhaps it formed in a region that was unusually devoid of the cold, dense gas needed to birth new stars. It may have gotten its vast size early on, but never managed to gather enough material to light up with a substantial stellar population, leaving it a vast, dark, and empty husk. The second theory is one of cosmic robbery. It suggests Dragonfly was once a more normal galaxy, but as it plunged into the dense cluster, its lifeblood, its star-forming gas, was violently stripped away. The intense pressure from the cluster's hot plasma would have acted like a torrential headwind, scouring the galaxy clean of the raw materials needed to make new stars, leaving behind only its old, red stellar population to slowly fade away. The discovery of the Dragonfly Galaxy and others like it has unveiled an entire new class of celestial objects, the ultra-diffuse galaxies. They are the ghosts in the machine of the universe, challenging our most basic assumptions about what a galaxy requires to form and to endure. They prove that the cosmos is filled with subtle, barely there structures, giants that walk on tiptoe, forever changing our perception of the galactic zoo. Hidden in the dense star fields at the heart of our galaxy, a new kind of stellar elder has been caught in the act of exhaling. Astronomers have discovered ancient red giant stars they call old smokers, suns that behave unlike any others we have known. For decades, these stars were overlooked, their strange activity mistaken for simple dimming or data errors. They would sit quietly for years, shining with a steady, predictable light, and then, without warning, they would begin to fade. Their brightness would drop dramatically, as if a veil were being drawn across them, and they would remain dimmed for months, sometimes even years, before slowly returning to their former glory. This was not the brief flicker of a planet passing by, but a long, drawn-out exhalation of cosmic soot. The key to their mystery lies in what they are puffing out. These are not gentle wisps of gas, but immense clouds of smoke-like dust, composed of complex molecules rich in carbon and other heavy elements. Imagine a star coughing up a storm of particles, a planetary mass of fine, dark dust that shrouds it from view. It is as if these ancient stars are smoking cosmic pipes, filling the space around them with a fog of their own creation. This bizarre behavior appears to be a secretive, late life phase for stars similar in mass to our own sun. After billions of years of stable burning, they have entered their final chapters, and this puffing seems to be a critical part of their death ritual. They are effectively recycling themselves, forging heavy elements in their furnaces, and then spewing them out into the galactic environment in these sporadic, massive belches of dust. This discovery transforms our understanding of how the building blocks of planets, and even life, are spread throughout the cosmos. These old smokers could be a primary and previously unknown source of the heavy elements that seed interstellar clouds, providing the raw materials for new solar systems to form. They had been hiding in plain sight all along, quiet custodians of cosmic chemistry, their vital contributions masked by their own smoky breath, while ancient stars smoke in silence. Another relic of stellar death races across the cosmos with unimaginable violence. This is the Cannonball Pulsar, a city-sized cinder of a dead star hurtling through the void at nearly 2.5 million miles per hour. It moves so fast it could travel from Earth to the Moon in a mere 6 minutes. Discovered by citizen scientists sifting through data from NASA, a Fermi Gamma-Ray Space Telescope, this object is a pulsar, the rapidly spinning, ultra-dense core left behind after a massive star ended its life in a supernova. But this one is different. It is a runaway, and it has left behind a perfect, incriminating trail. Stretching out behind it for 13 light years is a brilliant arrow of energized particles and magnetic fury, a tail of shocked gas that points directly back to the scene of the crime. This cosmic arrow is the key to the entire mystery. It points back to the center of a supernova remnant called CB1, a faint, expanding shell of gas that marks where the star originally exploded. The evidence is clear. The supernova that gave birth to this pulsar was profoundly asymmetrical. It was not a clean, spherical blast, but more like a cosmic bomb with a faulty casing. When the star's core collapsed, the resulting explosion must have been lopsided, with a powerful jet of material erupting from one side. The pulsar was kicked out like a bullet from a rifle, receiving a colossal gravitational slingshot from the uneven detonation. The incredible tale we see is the pulsar's wake, created as it plows through the faint, leftover debris of the supernova at supersonic speeds. Its powerful magnetic field acts like a dragnet, scooping up this tenuous material and accelerating it to near light speeds, causing it to glow with intense energy. The Cannonball Pulsar is more than just a fast-moving object. It is a direct testament to the chaotic, violent forces unleashed when a star dies. It is a piece of cosmic shrapnel, a runaway engine of destruction and creation, showing us that the end of one star can literally launch the beginning of a new, furious journey across the galaxy. The violence of stellar death can forge monsters that devour their own kin. Orbiting through the galaxy is a special class of cosmic predator known as a black widow pulsar. These are not solitary runaways like the Cannonball, but are locked in a tight, deadly gravitational embrace with a companion star. A black widow is a millisecond pulsar, a neutron star spinning hundreds of times per second, and it uses its incredible rotational energy to power a relentless assault on its smaller partner. The pulsar bombards the companion with intense radiation and a furious wind of high-energy particles, effectively cooking it from the outside in. This process, called reverse ablation, is a brutal form of cosmic evaporation. The pulsar's energy strips material away from the companion star's surface, blowing it into space and slowly eroding the star down to its core. Imagine a candle held too close to a blowtorch, its wax melting and vaporizing before it can even burn. That is the fate of the star trapped with a black widow. One of the most famous examples is a system named PSRB 1957+20, located about 6,500 light-years away. Here, the pulsar completes a full rotation every 1.6 milliseconds, and it orbits its stellar partner so closely that their entire dance takes just 9 hours. The companion is a brown dwarf, a failed star with only a fraction of the Sun's mass, and it is being utterly dismantled. The pulsar's radiation has heated one side of the brown dwarf to a temperature of over 6,000 degrees Celsius, hotter than the surface of our own Sun. This relentless heating creates a massive, bloated cloud of vaporized material that trails behind the doomed star like a comet's tail. These systems are invaluable cosmic laboratories. The extreme gravitational and magnetic fields around the pulsar, combined with the violent interaction of matter and energy, allow physicists to study the laws of nature under conditions impossible to recreate on Earth. We can observe how particles behave at near light speeds and how matter interacts with the most powerful magnetic fields in the universe. The ultimate fate of this cosmic drama is as inevitable as it is grim. The pulsar will continue to siphon material and energy from its companion, which may actually spin the pulsar up even faster. This stolen mass fuels the pulsar's wrath, creating a vicious feedback loop. Over millions of years, the companion star will be completely evaporated, its substance scattered to the solar winds. All that will remain is the isolated, rapidly spinning millisecond pulsar, a silent and dense relic orbiting the grave of the star it destroyed. Even as cosmic predators devour their partners, another world reveals a different kind of power, one of serene and unexpected beauty. The New Horizons spacecraft's flyby in 2015 transformed Pluto from a distant, blurry dot into a stunningly complex world, and its most breathtaking feature was a vast, heart-shaped plain of bright white ice stretching across its surface. This is Tombaugh Regio, a geological love letter written in frozen nitrogen. The left ventricle of this cosmic heart, a 600-mile wide basin named Sputnik Planitia, is one of the most geologically active places in the entire outer solar system. It is not a dead, cratered landscape, but a constantly renewing surface of convecting nitrogen ice. The process is both alien and familiar. The sun's feeble warmth at that immense distance provides just enough energy to slightly warm the solid nitrogen at the surface. This warmed ice becomes buoyant, causing enormous blobs of it to slowly rise, while cooler, denser ice sinks back down. This creates a slow-motion, cellular churn, like a lava lamp operating on a planetary scale over millions of years. The surface of the plane is fractured into irregular polygons, each cell marking the top of one of these rising and falling convection currents, erasing impact craters almost as soon as they form and keeping the heart of Pluto looking impossibly young. How did this colossal feature come to be? The leading theory is as dramatic as the heart itself. Scientists believe a colossal impact, billions of years ago, smashed into Pluto, blasting away a huge portion of its crust and creating a vast basin. Over eons, this deep depression became a cold trap where volatile compounds like nitrogen, methane, and carbon monoxide slowly accumulated from the thin atmosphere, pooling into a thick, slowly churning sheet of ice. The sheer mass of all this frozen material in one place may have even reoriented the entire dwarf planet, causing it to roll over until the massive heart sat squarely on the side, facing its largest moon, Charon, forever locking them in a gravitational embrace. The discovery of Pluto's beating heart was a profound reminder that worlds are not merely static rocks, but dynamic, evolving bodies with stories written across their faces. It forced us to redefine geological activity, proving that even in the deep freeze of the Kuiper Belt, worlds can remain vibrantly, wonderfully alive. Its heart is a testament to quiet geological power, but some worlds are born in a single, violent instant, around the brilliant young star Fomalhaut, a cosmic crime scene unfolded in plain sight, and for a while, we thought we had found a new world. In 2008, astronomers made a historic announcement. They had directly imaged a planet orbiting Fomalhaut, a star just 25 light-years away. This was not an inference from a star's wobble or its dimming light, but a visible point of light captured by the Hubble Space Telescope. It was a celebrated discovery, a dot of light they named Fomalhaut B, and it was moving exactly where a planet should be, tracing a path along the inner edge of a vast, icy debris ring that encircled the star. For years, it was a textbook example of a directly imaged exoplanet. But then, the star witness began to change its testimony. Subsequent Hubble observations revealed something deeply unsettling. The point of light was not behaving like a solid planet. Instead of moving on a steady, predictable orbit, it appeared to be expanding and fading. With each new look, the object grew larger and more diffuse, its light scattering into a faint, ethereal cloud. By 2014, it had vanished completely. It had simply faded from view, leaving behind only the empty track of its orbit. The planet was not just lost, it had disintegrated before our eyes. The conclusion was as dramatic as the disappearance. Fomalhaut B was never a planet at all. The truth was that astronomers had been incredibly lucky. They had not discovered a stable world, but had instead caught the immediate, brilliant aftermath of a cataclysm. What Hubble saw was the expanding debris cloud from a colossal collision between two immense planetesimals, each likely hundreds of miles across. The initial image captured the cloud when it was still compact and bright, a concentrated plume of pulverized rock and ice. Over the following years, the cloud continued to expand, like a puff of smoke dissipating in a gentle breeze. As it grew, its particles spread out, reflecting less light collectively until they became too faint for even Hubble to see. We had not found a planet, but had instead witnessed its violent birth, or more accurately, the destruction that clears the path for new worlds to form. This cosmic crash, frozen in time across 25 years of observations, gives us a rare, real-time look at the chaotic processes that shape solar systems. It is a stunning reminder that the universe is a dynamic and sometimes violent sculptor, and that what we see as a single point of light may be the echo of a catastrophe whose sound will never reach us. The catastrophic collision in Fomalhaut's system shows a single moment of destruction, but other cosmic events repeat their violent calls across the void. Fast radio bursts are among the most energetic and fleeting phenomena ever detected. These are not gentle signals, but millisecond-long flashes of radio waves that release more energy than our sun does in 80 years, all in a blinding instant. For a long time, every one of these bursts seemed to be a one-off event, a cosmic firecracker that flared and vanished forever. This made them nearly impossible to pinpoint or understand. Then, in 2016, everything changed. Astronomers discovered that one burst, first recorded in 2012 and cataloged as FRB 121102, was doing something extraordinary. It was repeating. This was the first known repeater, and its behavior shattered the assumption that all such bursts were caused by singular, catastrophic explosions. Here was a source that could flare up again and again, a cosmic alarm clock that refused to be silenced. The repeating nature of FRB 121102 was a game changer. Because it kept broadcasting, astronomers could train the world's most powerful radio telescopes on its location for extended periods. They successfully pinpointed its origin to a tiny dwarf galaxy over 3 billion light-years away, confirming that these immense energies were coming from far beyond our own Milky Way. The fact that it repeats immediately ruled out one-time cataclysms, like the explosive merger of two neutron stars or the final collapse of a star into a black hole. Such events are final. They cannot produce a second act, so what cosmic engine can power these repeated, unimaginably powerful eruptions? The prime suspect today is a type of stellar corpse known as a magnetar. Imagine the core of a dead star, a neutron star, but with a magnetic field so incredibly powerful, it is 1,000 trillion times stronger than Earth's. This field is under immense strain, and scientists believe it can suddenly crack the star's solid crust in a starquake. This seismic event would release a titanic wave of energy, accelerating particles to near light speed and blasting out a coherent beam of radio waves that we detect as a fast radio burst. The repeating nature suggests that these magnetars can experience multiple quakes, settling down and then fracturing again under the incredible stresses. Yet, even this compelling theory does not explain every detail. Some repeating bursts show patterns or strange variations in their polarization, a property of light that suggests they are moving through incredibly turbulent and magnetized environments, perhaps near the event horizon of a massive black hole. The mystery deepens with the discovery that some repeaters are sporadic, while others, like FRB 180920, which comes from a nearby spiral galaxy, are remarkably active and predictable. Each new detection adds another piece to the puzzle, but the full picture of what creates these brilliant, repeating cosmic screams remains one of the most thrilling open questions in modern astronomy. While these cosmic flashes scream across the universe, they also illuminate the darkness between the galaxies, revealing a secret that had been hiding in plain sight for decades. Cosmologists were facing a profound embarrassment. They had a very good model for how the universe began, the Big Bang, which precisely predicted how much normal, everyday matter should exist. This is the baryonic matter, the protons and neutrons that make up stars, planets, and us. Yet, when they added up all the visible matter in every galaxy, star, and gas cloud they could find, they came up shockingly short. Nearly half of all the ordinary matter in the universe was simply missing. It was a cosmic accounting error on the grandest possible scale, a universe that seemed to be missing its own ingredients. For years, this was one of the most frustrating puzzles in science. Where could an entire universe worth of atoms be hiding? The answer was not in the bright islands of galaxies, but in the vast, dark oceans between them. Astronomers theorized that this missing matter was spread through the cosmic web, the fundamental architecture of the universe. This web is a network of invisible dark matter filaments, and along these filaments, they believed, ordinary matter was drawn into vast rivers of incredibly hot, incredibly diffuse gas. This is the warm, hot intergalactic medium, a soup of ionized particles so thin it is a better vacuum than any we can create on Earth, and so hot it glows only in faint X-rays. For a long time, it was effectively invisible, a ghost in the cosmic machinery. The breakthrough came from an unexpected tool, the fast radio bursts we just discussed. Think of a fast radio burst as a brilliant, momentary lighthouse. As its flash travels billions of light years to reach us, it passes through this diffuse intergalactic material. The burst is not a single wavelength, but a spread of frequencies, and the tenuous gas in the cosmic web slightly slows down the lower frequencies, causing a delay compared to the higher ones. By measuring this delay with exquisite precision, astronomers can essentially count the number of electrons the burst encountered on its long journey. Since this hot gas is made of ionized atoms, stripped of their electrons, counting the electrons directly tells you the amount of normal matter it contains. It is like using a flash of lightning to illuminate the fog, allowing you to measure its density. When scientists applied this technique to numerous fast radio bursts, the numbers finally added up. The decades-long hunt was over. The missing matter was not missing at all. It was found woven into the fabric of the cosmic web itself, a vast, hot atmosphere connecting all the visible structures in the cosmos. This discovery did more than just balance the cosmic books. It confirmed our deepest theories about the universe's structure, proving that the empty space between galaxies is not empty at all, but is the true reservoir of the universe's ordinary soul. The universe is missing most of itself. We have mapped the stars and the galaxies. We have traced the paths of light across billions of years, and yet we find that everything we can see, every planet and every sun, accounts for a mere 5% of the cosmos. The rest is a profound and utter mystery, dominated by a ghost we call dark matter. This is not a single, strange object, but the hidden architecture of reality itself, an invisible scaffold that holds the entire universe together. We cannot see it, touch it, or interact with it in any known way, yet we know it is there because of the undeniable pull it exerts on everything we can see. The first compelling clue came from the way galaxies spin. Consider our own Milky Way. The stars on the outer edges of a spiral galaxy orbit its center, just as planets orbit the sun. According to the laws of gravity, these distant stars should be moving much more slowly than the ones closer in, just as Pluto crawls along its orbit compared to Mercury. But when astronomers measured these rotations, they found something shocking. The outer stars were moving just as fast as the inner ones. The galaxy was spinning so quickly that it should have flown apart, tearing itself to pieces. The only explanation was that it was embedded in a massive, invisible sphere of matter, a dark halo whose immense gravity was the only thing holding the speeding stars in their tracks. This ghostly presence reveals itself in another, even more dramatic way, through a phenomenon called gravitational lensing. Einstein predicted that a massive object warps the fabric of space-time, bending the path of light that passes near it, like a lens. When astronomers look at huge clusters of galaxies, they often see distant background galaxies stretched and distorted into faint arcs and rings. The amount of bending is far too great to be caused by the visible matter in the cluster. It is the gravitational signature of an immense, unseen mass of dark matter, distorting our view of the cosmos and magnifying the light from objects behind it. This same dark matter is the reason our universe looks the way it does. In the early cosmos, the gravitational pull of these invisible concentrations acted as seeds, gathering the normal hydrogen and helium gas that would eventually condense into the first stars and galaxies. Without dark matter, the universe would be a formless, featureless sea of gas. We would not exist. So what is this elusive substance? The hunt for its identity is the single greatest unsolved problem in modern physics. The leading candidate is a hypothetical particle known as a WIMP, a weakly interacting massive particle. As the name implies, it would be heavy, but it would interact with normal matter only through gravity and the weak nuclear force, making it incredibly difficult to detect. Another promising idea is the action, an ultra-lightweight particle that could permeate space like a ghostly field. To catch these phantoms, scientists have built extraordinary experiments deep underground, in old mines and tunnels, shielded from cosmic rays. They use vats of ultra-pure liquid xenon, waiting for the once-in-a-lifetime tremor that might occur if a dark matter particle ever, fleetingly, bumps into an atomic nucleus. So far, the detectors have remained silent. we are surrounded by an ocean of darkness, a sea of invisible matter that flows through our bodies and our planet every second, completely unnoticed. We feel its gravity shaping the cosmos. We see its shadow in the bent light of distant galaxies, and we know it is the master architect of everything we see. Yet its true nature remains just beyond our grasp, a fundamental secret of existence waiting to be unlocked. A single ghost from the depths of space once passed through the Earth, and it carried an address. Deep within the Antarctic ice, at the South Pole, lies one of the strangest observatories ever built. It is not a telescope of mirrors and lenses, but a colossal detector called IceCube, composed of over 5,000 sensitive light sensors buried more than a mile beneath the surface, frozen into a cubic kilometer of pristine ice. Its mission is to catch phantoms, particles called neutrinos. Neutrinos are the universe's ghosts. They are nearly massless, carry no electric charge, and can fly through entire planets as if they were not even there. Trillions pass through your body every second, completely unnoticed, but on September 22, 2017, IceCube caught one that was different. This neutrino, later named IceCube 170922a, was not like the others. It arrived with an incredible amount of energy, 1 billion times more powerful than those produced in the sun's core. It slammed into an atomic nucleus in the clear Antarctic ice, and in that violent collision, it created a new particle that radiated a faint, telltale blue glow as it traveled. This flash of Cherenkov radiation was picked up by the sensors, and from its precise pattern, scientists could calculate not only the neutrino's immense energy, but also the exact direction from which it came. For the first time, we had a cosmic zip code for one of these ghostly messengers. The alert went out across the global astronomical community. The coordinates pointed back to a spot in the constellation Orion, and when telescopes swiveled to look, they found something extraordinary. There, 4 billion light-years away, was a blazar. A blazar is the universe's most powerful and violent particle accelerator. It is a supermassive black hole at the center of a distant galaxy, millions of times heavier than our sun. This monster is actively feeding, pulling in vast amounts of gas and dust. As this material spirals into the abyss, some of it is channeled by immense magnetic fields into a pair of jets that blast outward from the black hole's poles at nearly the speed of light. We on Earth had the incredible fortune to be looking directly down the barrel of one of these jets. This blazar, known as TXS 0506 plus 056, was in a period of intense activity, and it was firing a deadly beam of radiation and particles directly at our solar system. The high-energy neutrino was a piece of that beam, a single subatomic bullet that had traveled for 4 billion years to strike our detector. This was the dawn of multi-messenger astronomy. For the first time, we did not just see the universe, we felt it. The neutrino was one messenger, the gravitational wave would be another. Astronomers combined its data with observations from gamma-ray telescopes, which saw the powerful high-energy light from the blazar's jet, and with optical and radio telescopes that monitored its outburst. By overlaying these different signals, they could pinpoint the source with absolute certainty. This single ghost particle opened an entirely new window onto the most violent events in the cosmos. We are no longer just stargazers. We have become cosmic listeners, hearing the faint whispers of particles that have journeyed from the heart of a celestial monster, learning to read the universe through a conversation of light, gravity, and ghostly messengers. That ghostly neutrino was a messenger from a violent cosmos, but its journey was shaped by a force far more mysterious and powerful than any black hole. The universe is not just expanding, it is accelerating, flying apart at a rate that grows faster with every passing moment. This discovery, one of the most shocking in the history of science, points to a presence that dominates the cosmos, an entity we call dark energy. It is the ultimate strange object, one that is not an object at all, but a property of empty space itself, and it is slowly tearing the fabric of reality apart. The story of its discovery began with dying stars. In 1998, two independent teams of astronomers were studying a specific kind of stellar explosion, a Type 1, a supernova, which always explodes with the same intrinsic brightness. This makes them perfect cosmic mile markers, or standard candles. By measuring how bright these supernovae appeared from Earth, the scientists could calculate their exact distance. And by measuring the redshift of their light, they could determine how much the universe had stretched since the moment they exploded. The expectation was that the expansion of the universe, set in motion by the Big Bang, should be slowing down over time because of the relentless pull of gravity from all the matter, both visible and dark. But the data told a different, astonishing story. The distant supernovae were significantly fainter than they should have been. This meant they were much farther away than anyone had predicted. The only possible explanation was that the expansion of the universe was not slowing down. It was speeding up. Some mysterious repulsive force, stronger than the collective gravity of everything in existence, was pushing the galaxies apart. This dark energy is now calculated to make up about 68% of the entire cosmos. Its existence forces us to confront the ultimate fate of everything. If this acceleration continues unchecked, the most likely outcome is a cosmic event known as the Big Freeze. Over trillions of years, as space stretches faster and faster, distant galaxies will be pushed beyond our observable horizon, their light never able to reach us again. The universe will become a much darker, colder, and lonelier place, with isolated islands of stars fading away into an ever-expanding void. But there is a more dramatic and terrifying possibility: the Big Rip. If the strength of dark energy increases over time, it could eventually overcome all the forces that hold things together. First, it would tear apart galaxy clusters, then individual galaxies. As the acceleration grows, stars would be ripped from their solar systems. In the final moments, planets would be shredded, and then atoms and atomic nuclei themselves would be pulled apart. The very fabric of spacetime would be torn asunder. So what is this force that holds such power over destiny? The leading theory is that dark energy is the cosmological constant, a concept first proposed by Albert Einstein and later abandoned. It is the energy inherent to the vacuum of space itself. According to quantum physics, empty space is not truly empty, but is a seething foam of virtual particles popping in and out of existence. This vacuum energy could be generating a constant, repulsive pressure that drives the acceleration. The problem is that the theoretical calculations for the strength of this vacuum energy are wildly, astronomically incorrect, off by a factor of 1 followed by 120 zeros. This is the largest discrepancy between theory and observation in all of science. Alternative theories suggest dark energy is not a constant, but a dynamic energy field, nicknamed quintessence, that evolves and changes over time. Its strength could be weakening or growing, directly influencing which fate, the freeze or the rip, ultimately awaits the cosmos. Dark energy is the greatest puzzle we have ever faced. It is the silence that is pushing the galaxies apart, the nothingness that holds the key to everything. We are living in the brief, bright moment when the universe is still rich with stars and galaxies, a moment made possible only because we have caught the first faint whispers of the void that will one day consume it all. This cosmic acceleration is driven by an unseen force, but sometimes the violence of the universe is starkly visible. A supermassive black hole is on the run. Hubble Space Telescope data has revealed a breathtaking trail of light, a contrail of newborn stars stretching 200,000 light-years across the void, and at its tip, a colossal black hole weighing as much as 20 million suns is hurtling away from its galaxy. It is not drifting, It is fleeing, plowing through the dense gas of intergalactic space like a ship through a cosmic ocean. The most astonishing part is not its escape, but the creative destruction it leaves behind. As the black hole rams into this primordial gas, the shockwaves compress the material, triggering a firestorm of star formation directly in its wake. It is a bizarre paradox. A monster that destroys on a galactic scale is simultaneously painting a line of new suns across the darkness. How does something with the mass of millions of stars get thrown out of its home? The explanation is a gravitational thriller, a cosmic slingshot effect. Astronomers believe this began when two galaxies merged, each with its own central, supermassive black hole. These two giants would have begun a tight orbital dance, slowly spiraling toward each other. Then, a third black hole, perhaps from a smaller galaxy that was also consumed, entered the scene. This three-body interaction is a recipe for chaos. The complex gravitational tug-of-war can fling one of the black holes clear out of the galactic core at tremendous speed, while the other two are sent spiraling inward, eventually merging. This runaway behemoth is likely the result of that violent ejection, a casualty of a galactic collision that happened billions of years ago. The significance of this discovery is profound. It provides the first strong observational evidence for these chaotic, multi-black hole interactions that theorists have long predicted. It shows us that the evolution of galaxies is not always a slow, stately process, but can be punctuated by these catastrophic events that can literally eject their central engines into the great nothing between the stars. This runaway black hole is more than a curiosity. It is a fossil record of an ancient, epic battle, a direct glimpse into the violent forces that have sculpted the universe we see today. Even a runaway black hole carving a trail of stars seems almost predictable compared to the latest discovery to haunt our maps of the sky. They are called odd radio circles, or ORC, and they are exactly that faint, perfect circles of radio emission that appear out of nowhere in the deep field surveys. Discovered in 2019 by Australia's ASCAP radio telescope, these ORCs are visible only in radio wavelengths, completely invisible to optical, infrared, or X-ray telescopes. They are cosmic ghosts, only revealing themselves when we listen to the universe in the right kind of light. Their most staggering feature is their sheer, incomprehensible scale. A single ORC is multiple times larger than our entire Milky Way galaxy. If one were placed in our neighborhood, it would dominate the night sky, a ring of energy wider than the full moon. The immediate and unsettling question is what could possibly create such a vast, circular structure. The leading natural explanation points to a galactic wind of unimaginable force. The theory suggests that a massive burst of star formation within a central galaxy could create powerful shockwaves, blowing a spherical bubble of fast-moving particles out into intergalactic space. We would be seeing the circular rim of this colossal bubble, a shock front illuminated by synchrotron radiation, where electrons spiral at near light speed along magnetic field lines. Another, more dramatic idea is that we are seeing the aftermath of a titanic explosion, perhaps the merger of two supermassive black holes, which sent a spherical shockwave racing outwards for millions of years. But the most speculative and mind-bending hypothesis is that an ORC could be the throat of a wormhole, a gateway in spacetime. Its intense gravitational lensing warping radio waves from behind it into the perfect circle we observe. While this is considered far less likely, it highlights just how baffling these objects truly are. They do not correspond to any known type of nebula, supernova remnant, or galaxy. They represent a completely new class of astronomical phenomenon, one we lacked the sensitivity to see until now. The discovery of ORCs is a humbling reminder that our cosmic maps are still filled with blank spaces, marked "Here be dragons." and that the universe continually invents new forms of wonder and mystery, just waiting for us to look in the right way. Yet even these ghostly circles may be less strange than a chill from the dawn of time. Woven into the very first light of the universe is a cold spot, a cosmic bruise so vast and so cold, it defies simple explanation. This is the Great Cold Spot, a mysterious region in the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space. This ancient light is not perfectly uniform. It has tiny, expected variations in temperature, hot and cold patches that are the seeds of all future galaxies. But the Great Cold Spot is different. It is a colossal anomaly, a patch of sky significantly colder than its surroundings, stretching over 1 billion light-years across. Its sheer size and profound chill are difficult to reconcile with our standard model of cosmology. According to our best theories, such a large and cold region simply should not exist. It is a statistical outlier so extreme that it challenges our understanding of how the universe was born, what could have left such a mark on the fabric of reality. One leading theory proposes that the Great Cold Spot is a shadow cast by a cosmic void, a supervoid. Imagine a region of space that is mostly empty, a vast bubble containing far fewer galaxies than average. As light from the cosmic microwave background travels through this underdense region, it must climb out of the void's gravitational well. This struggle against gravity saps the light's energy, causing it to redshift and appear colder to our telescopes. It is a process known as the integrated Sachs-Wolf effect, a subtle but measurable phenomenon. The problem is one of scale. For a supervoid to cause a chill this significant, it would need to be unimaginably vast and profoundly empty, far larger and emptier than any void we have ever observed. The known voids, like the Boötes void, do not seem to be sufficient to account for the extreme temperature drop. The evidence for a supervoid in that exact location is also weak and controversial, leaving the cold spot without a clear culprit. This failure of a simple explanation has opened the door to more speculative and thrilling possibilities. Some cosmologists have proposed that the Great Cold Spot could be evidence of a cosmic collision, a bruise left from an impact with another universe in the vast multiverse. In this mind-bending scenario, our observable universe might have bumped into a neighboring bubble universe in the first instance after the Big Bang. The energy released in such a collision could have created a localized region of cooler temperature, an imprint forever frozen into the cosmic background. While this is a highly speculative idea, it underscores just how profound a puzzle the Great Cold Spot represents. It is a blemish on our most fundamental map of the cosmos, a cold whisper from the beginning of everything that our best models still cannot fully explain. It stands as a permanent challenge, a reminder that the first light of creation may still hold secrets we are only beginning to decode. From rogue black holes to phantom galaxies, the cosmos has revealed itself as a gallery of the impossible. We have journeyed past dying stars that smoke like cosmic pipes, and through voids of staggering emptiness. We have felt the pull of dark giants we cannot see, and witnessed the ghostly circles that defy all classification. Each of these 25 objects, from our own solar system to the edge of the observable universe, tells the same profound story. Reality is far stranger, more violent, and more beautifully chaotic than we ever dared to dream. These are not mere anomalies. They are signposts pointing toward a deeper truth, that our understanding of physics and existence is still in its infancy. The universe is not a placid, predictable place. It is a living, breathing entity of endless mystery, where the rules can be bent and where new wonders are waiting in the next patch of dark sky. So the next time you find yourself beneath a clear night sky, look up. Remember that within that vast darkness drift worlds with hearts of ice, stars that exhale soot, and energies that bend the fabric of space and time. Let that feeling of wonder take hold. The greatest discoveries are still out there, waiting for the next curious mind to find them. If you are ready to continue the journey into the unknown, subscribe and join us as we keep exploring the deepest secrets of the